The purpose of this video is simply to introduce you to the concept of arrays, and it's part of the AS Computer Science course. What I want to do over this short video is just introduce you to the technical terms that comes around about arrays. But before we do that, let's just secure what we actually mean. What we want to do, we want to take the concept of a standard variable. Let's think about creating something, a simple variable as a simple assignment that you might see in any programming language. By the way, that's an underscore. It doesn't look like it, but oh well. My underscore value equals 13. If you thought that was a minus, then you need to remember you can't do calculations this side, but that's not what this video is about. So I'm going to stop talking about it now. My underscore value is equal to 13. So what's effectively happening here? Well, you know already that the computer has got main memory. It's got an area of memory made up of RAM and ROM, but we're only interested in the RAM side. And we can picture that memory as just simply a whole load of memory. It's often represented in this way. The computer simply grabs a piece of memory out of this area of RAM. This is often referred to, because we just dump things into here, it's often referred to as a heap or the heap. Anyway, we want to create this. So what the computer does is it creates an area, or takes an area of memory that has a memory address, and it basically ends up creating a pointer where the name my value points to that single memory address, and that now becomes 13. If I change my value at all, let's say my very next line was my value is equaled to 4, then the way computer memory works is that this same memory location is being used, but now this value is lost, never to be seen again, and it's replaced with the value 4. I put a cross through there, but the data is lost. The 13 is gone. You cannot recover it. There's no undo for the 13. So it's now being replaced with the value 4. We have a single memory location which my value is pointing to. And that is a simple variable. That's just what a variable is. And we know it's a variable because the contents can change. So we can see a variable as nothing more than a simple box. So let's have a look at that again. Oh, we use red on yellow, but we can put up with that. Our eyes can take the strain. My value basically looks like a single memory location. Now, a memory location in a computer can have any number. I'm going to use a very old-fashioned concept of memory location. I'm going to start my memory location at 0080, and any oldies watching this video may well go, I know what you're doing, but it doesn't matter. So my value, which is my variable name, is pointing towards the memory location that has actually got this hex address. The dollar simply tells me that I'm talking about a memory address and not just a number. That's all. That's for the human beings. This, though it's 0080, it's actually a hex value. So this is a hex value here. And we frequently, in fact, I can't think of any circumstances where you would not use a hex value for memory addressing. And that's it. That's how a variable works. But what if I want to store more than one value? What if I've got a set of ages of people, and I'm running a club, and that club's got people in it, and I just want to store their age, nothing else. I don't want anything else about them. They already bore me. But I'm just going to have club ages. Well, I can't just store them in a single memory location, because if I do that, if I want to store 5 ages, I can only ever store one of them. That's easy enough. What I could do is I could store the first age in club ages. And then I'm going to create another variable called club ages 2. And maybe I'll just put a 1 onto there, and then I'm going to have club ages 3. And I can keep doing that. Now I said 5, but imagine if we got 500. That's a seriously tough thing to remember. And what if I've created 500 memory addresses like this? 500 variables, and we get 501 members. I've got to go back into my code and build it, and so on and so forth. So maybe there's a way that I could fix this. So one way of doing that is to create something called an array. So let's create an array. Don't use my, this is a club. It's not just my, it's our club. Anyway, let's create that variable effectively. So let's create club ages. And what we're going to do here is we're going to create an array. And what that looks like is it is a sequential series of memory locations. So now I haven't got one memory location, but I've got 2, 3, 4 and 5. 1, 2, 3, 4 and 5. Now if you remember with my lovely example of an address, and I'm only going to give the end part. We remember the first part. Hopefully you remember the first part was 00. So I'm going to just go for $80, if that's all right. Well, the next address is $81, and the next address is $82, and the next address is $83, and the next address is $84. And that's because I've defined my array, so I can declare club ages square, and then I can define I want this to be 5 as, and then I can declare the data type if I wish to, because I'm using ages, I'm going to declare it as, let me move that across a little bit, declare this as integer. Okay, I can put the whole word integer there if I really wanted to, rather than shorten it. So what's the computer done? When I did this declaration, it doesn't just grab one memory location, but it looks for a memory location where it can grab 5 consecutive pieces. They are run one after the other after the other. Now what does that mean? Well, that means now that I don't talk about club ages. I can't simply say club ages equals, because this is now not one memory location. What I need to do is I need to reference the position of this index, of this value. So I could say club ages 0 equals 13, and then 13 gets put into there. And I could then use the same thing. Let me move this up a little bit. I could then set this out as club ages 1 equals 4. And what that means is that 4 would be put in here. So what's this value here? Well, this is called the index, and it defines the position in the array. And if we think about the memory location, when we talk about club ages, the default address for club ages would be the initial address 80. So if I wanted to just simply place something in index 0, it would simply go to 80. That's index 0. But if I want to go to club ages 1, I would go to 80 and move on 1 box. 2 is there, 3 is there, 4 is there. The value here, the index, is actually what we call the offset. Now the offset is how far off your initial address are you going. 0 means I'm not going off at all. 1 would mean I'm going 1 off. 4 would mean I'm going 4 off. So even though I declared my array, there, even though I declared my array as a 5, it's got 5 pieces, but the highest index happens to be 4. Now, this is not true with all programming languages. Let me explain that a little bit, because that's fun, isn't it? Right. Club ages points towards a memory location, and we've already declared it as 5. So most programming languages, 2, 3, 4, 5. Most programming languages would start with index 0, 1, 2, 3, 4. Remember that this is the index. This is known as zero indexing. As I say, most programming languages use zero indexing. But there are quite a few programming languages which don't. They start from position 1, 2, 3, 4, and 5. Now that means that the programming language has got to remember to deduct 1 from this index, so that for the offset required, this is still an index. It's just a different index, and this is called 1 indexing. This is because human beings naturally, when they first come into computing, expect 1 indexing. It feels right when you first use it. Once you get into programming, it feels wrong. You can't really feel why it felt right in the first place. But it is correct. And there are some old languages, and languages such as Fortran use 1, while languages such as Python and Java will use 0. So 0 indexing and 1 indexing. And so we've been introduced to one term already. And that is indexing. The index. The index defines the position within the array. Position in the array. Now, we've got the lower bound and upper bound. These are two terms you'll also come across. The lower bound of an array is the lowest value. So the lowest position within the array. By default, that is either 0 or 1. Then what we've got is, if we've got the lower bound, we must have an upper bound. And the upper bound is the highest position. Now the highest position by default is either, and this is where this indexing comes to fun. Comes to fun? That's not even English. Anyway, it doesn't matter. That's where it becomes fun. Is that it's either, if we're using 1 indexing, as we saw earlier, if we think about the 1 indexing, and let's just have a quick look back at that, the highest value is 5, which actually matches our declaration for the array. So in this case, 1, 2, 3, 4, 5 boxes, and our index value is 5. So therefore the upper bound of this 5 is the same as the length of the array. So if we go down to here, in 1 indexing, I didn't put ing at the end, let's put it, yeah, there we go. 1 indexing, the upper bound, and I'm going to put UB, and I'm going to put an arrow, so we now know that means upper bound. Upper bound is equal to the length of array. Often you'll see length, by the way, referred to as len. Length of array tells you how long it is. But for a 0 indexing system, because we start at 0, and let's just look back at that one as well, it's not 5 but it's 4. Since it's 4, it's 1 less than the length. So if we're using 0 indexing, we know that the upper bound, and again that's still the same letters, UB for upper bound, is equal to the length of array minus 1. So we now know the upper bound and we know the lower bound. Now we might decide to alter those as we're using different tools. Later in a video to come up soon, we're going to see a situation where we will want to redefine the upper and lower bound of the array. It doesn't actually physically change the array. The array would still be 5 in our case, but there are certain circumstances where we want to move the concept of the upper and lower bound for certain algorithms. Now the important thing with arrays is, let's go back to our concept here. We have the 5 boxes and they're being defined there, but let's go back to our heap. The computer would have grabbed an area of memory in here with 5 neat little boxes in a nice row at the point of declaration. 2, 3, 4, 5. Now the problem here is we could create then another variable, and the computer decides that this place here is the next available slot. That means that our array now couldn't use that, and our concept of the offset would mean we couldn't use this one. We'd go 0, 1, 2, 3, 4, 5 would not be a possibility. So arrays are fixed. At the point of declaration. What that means is we cannot define the size. We can choose the values. All 5 values can change as often as we like, but we can't add a 6th or a 7th or an 8th array element. By the way, that's what each point is called, an element. So we can't define a new one. We can't change my ages from a size 5 to a size 6. That's not possible. There are routines that do something called redimensioning, but let's not worry about that at the moment. That does introduce an interesting word we want to look at in a moment. But redimensioning is not what it seems to be. It's a neat little tool, but it's not just simply adding something to the end. Now, let's have a look at that word I just used. Let's go back down to our little list of words down here for no apparent reason, because I'm going to move them off the screen. Let's go back to there and let's go to here. Dimension. Dimension is basically the size of the array. Now what does that mean? So what that means is we defined our array. So we created, let's create a new one called my array 10. This has 1 indices. 10 indexes but 1 indices. So this makes this that's its dimension. It's a 1-dimensional array. Now the other thing to do with that is one last term to look at is shape. Shape is how long that dimension is. So in this case, the shape of my array is exactly what we can see there. It's 10. So that's the shape. How can that change? Well, I could create something called my array, I'm going to try not to create it on the slant now. I'm going to create that as 2, 4. Now, the way of diagrammatically, in a diagram, diagrammatically representing this is not something you really want to get into, but it's a good thing. This is not something you want to visualize them at, but initially when you start off it works quite nicely. 2, 3, 4. 0, 1, 0, 1, 2, 3. As you can see here, we haven't just got one column, but we've got 2 columns. So this is the shape there of the array. But the dimension of our array is 2, because there are 2 dimensions. This is a 2-dimensional array. Now you can go beyond 2, you can create as many dimensions as you like, but this is where this diagram falls down. Once you get past 3, unless you're quite happy to move into the 4th dimensional shapes and 5-dimensional shapes and things you cannot even visualize, it's not worth it. And it's not how the computer sections it. The computer does not create memory in that form, and it still uses offsetting and things like that. But we don't have to worry about that. What you need to know about is that the arrays can be 1 or 2 dimensions. That's the dimension that's been declared. And its shape defines how many elements there are in each of those dimensions. Upper bound, lower bound, and what do we mean by index. That's arrays. When we come back next time, we're going to have a look at suitability. But that's till next time. Bye.